Hey guys, this week for homework number 5, we're going to start talking about something new, which is exponential functions. It's just a regular M. I'm sure why it ends up being so tall. But basically, if you're looking through the topics, then they're probably going to look a little bit not the same as what you have seen in the past, although there's some similarities to stuff we've done. So the first topic is D6H, and it's evaluating an exponential function, which really just means plugging a number in to an exponential function and then solving. So an exponential function has the x in the exponent, which is why it's called exponential. So like this, 12 to the x power plus 7. So x is the exponent. And so if it says find f of 0, it's really saying change out the x for 0 and figure out what you end up with. So if I do that, 12 to the 0 power plus 7. So anything to the 0 power is 1. So this is really 1 plus 7, which is 8. So f of 0 equals 8, which really means that on this graph, there is a point where x equals 0 and y equals 8. So this is a point, which is why we use this notation. So you can see the input and the output at the same time. This is called function notation. And it just is telling you what to plug in for x. It's not telling you to multiply f times x. It's saying plug in 0 for x and see what you get. So if I do that here, 8. So now let's try a few more. So f of x equals 7 to the x power. So if I do f of 1, I'm going to have 7 to the 1, and anything to the 1 power is just itself. All right, f of x equals 4 times 8 to the x power. So remember PEMDAS. PEMDAS never stops working. So in this situation, if you're thinking about it, it's exponent first and then multiplication. So you don't want to do 4 times 8 here, even though it seems kind of like an intuitive thing to want to do. Really what you want to do is you want to plug in that number 1 here to get 8 to the 1 power. So exponents first, 8 to the 1 is 8, and then 8 times 4 here is 32. So exponents first and then multiplication. Very common mistake. Students accidentally multiply first. F of x equals 3 times 8 to the x power plus 7. Notice I move the x inside. It doesn't really matter. We don't really need those parentheses around the 8. Well, you do need the parentheses around the 8, but the x can be inside or out. It doesn't matter. So here I'm going to plug in 3. So 3 times 8 to the 3rd power plus 7. So I do feel like if you guys need to use a calculator, you certainly can. There's no reason that you need to be doing multiplication like this. So if you have a calculator in front of you, you can use it. Also, I recommend Desmos is a good calculator to use in case you don't have a calculator. So if I want to make this to the 3rd power, I have to click A to the B like that, and then type 512. So this is 3 times 512 plus 7. So then if I multiply times 3, I get 1,536 plus 7. $1,543. So obviously, I'm sure you've heard people talk about the idea that exponential things grow very fast, like the idea that, for example, COVID spreads exponentially as opposed to linearly is because of this idea. The idea that it gets big very, very quickly. It doesn't, just keep adding a few every week or whatever. It's actually multiplying upon itself every time. So I'll let you go through those, but don't be afraid to use a calculator if you need to. Okay, as far as matching the graphs, let's talk about this. So one of the easiest things to do when you're talking about exponential form, actually, let's look it up and see. If I was you and I was like, what is exponential form? Let's do it this way. Exponential function. So exponential functions definitely have this shape, this curved shape. And that's that idea of it either getting big really fast, or if it's going down, it's decreasing really quickly over time. And it has a setup. I just wanted to find. Okay, so this is what I wanted to show you, but this y equals a times b to the x power, this is considered an exponential function, like the form for it. And so you can see that there's a few different pieces, kind of like with y equals mx plus b, how we have a few things to help us with graphs and things like that. Same kind of thing here, it's just in a different format. And so hopefully you know, obviously, that this is your exponent in your base, and then this is your constant here. When you're matching, you'll notice like on this, it has a plus at the back. And so that plus, if you add a number here, like a plus whatever number here, that's going to make it cross the y-axis at this place, at this number. So this is like the y-intercept when you add or subtract a number to the back of this format. And then this number also tells you which direction it goes. If it's positive, it's increasing. But if it's negative, then you're going to have a graph that's going down or decreasing. So this also affects the direction it's going. So these are some ideas when you're trying to match that you can, but it's like if I look at this one, y equals 4x plus 4. Y equals 4 to the x plus 4 basically is the same as saying 1 times 4 to the x plus 4. So since this number in front is positive, that means it's going to be going up. So I know this one, and this last one are possible. This one is not because it's going down. So it's not going the right direction. And then the other part I know is that it crosses the y-axis at 4. So it's basically pushed up 4. So if you look, oh, this is what I mean when I say it crosses at 4, it creates this asymptote here. So this is called an asymptote when it has that dotted line like that, which means that it gets really close to that line as you move back that way, but it doesn't actually ever touch it. So this dotted line is called an asymptote because it never goes underneath it. It trends toward it, but never actually crosses it. So it's at 4 here, which matches with that. So I'm going to choose this. Okay. All right, this one goes down. So I know I have to have a negative number. So it has to be one of these two. And it looks like the asymptote on this one is at -2, which it's going down and crosses at -2. So it would be this one. Ooh, negative. So it should be facing down, right? So it has to be either the second one or this last one. And then the asymptote is at -4. So that one's not down enough. All right, the levels on here doesn't change. So it's basically the same thing over and over again. The asymptote here is 0, which is why there's no plus number at the back. I can tell the direction because it's going down, right? So it should be negative in front. And then if I'm looking at the difference between those two, so I have y equals -1/3 to the x power, or y equals -3 to the x power. One of the things you could do, because really what you're kind of handling right now is just learning how to interact with a new type of function. You could go into your graphing calculator and try graphing them. If we were in class together, I probably on this lesson would give you a graphing calculator and say, hey, why don't you play around with what it looks like and see? So there's my -1/3 x. Oh, I don't need that. And then I'm going to come over here to my keyboard and put in where I can type in an x there. So I end up with that shape. Ooh. And so then if I'm looking at the other one, I -3 to the x power. And hopefully you can tell that what happens. So now you're almost comparing what happens when you have a fraction in for the base of the exponent as opposed to a bigger number like 3, and it switches the direction, right? So if I'm trying to match it to the one we were just doing, it would have to be this one. It's the blue one, right? So blue is the negative 3x. Good job. So that's my suggestion for this. Use a calculator if you need to. Desmos.com is a really good graph. As far as domain and range. So for domain and range, it's really asking you how, like what part of X does it exist on? And this graph goes forever in this direction. It goes to the left forever because of that arrow. And it also is traveling up and to the right forever, which really means it's going to end up covering every X eventually. If you make the graph big enough, it'll cross over every part. So here, when it says all real numbers, that's what it means. It means the domain is all real numbers. X is all the way across. Range is the other direction. It's going up and down. So on this one, if you look at where it doesn't exist, this graph never exists when it's under 0. So it has to be a positive number. It starts, if you're thinking about being at the bottom and moving up, there's no graph, no graph, no graph until you hit 0. And then after 0, there's a graph everywhere, right? Because this arrow keeps going forever in that direction. So it starts at 0 and it keeps going forever. So y has to be greater than, but it's not equal to, which is why it's dotted. So it gets closer to that line and it looks like it touches it, but if you actually zoom in, it never actually does. It keeps getting closer and closer and closer. So y has to be greater than 0. Range of this, again, starts at 0. So y has to be greater than 0. Domain, so that's X, and I'll give you a clue. The domain, so this is topic A and Z, okay? The domain of all exponential functions is all real numbers. So every exponential function is going to go forever in both directions as far as left to right goes. So if they're asking for a domain on this, it's definitely all real numbers. Range is always going to be wherever that asymptote is, and then either going up or down depending on what's going on. So let's look at the last topic, which the last topic is having you look at an equation. So I'm going to guess you're probably not going to right away be able to look at that equation and just see things. So again, this would be a good time to go in and use your graphing calculator. Oops, 5, 6. And let's get rid of that one. So if you look at this, it looks like this. So if I'm trying to find my domain, which I don't really need to look, but because domain is going to be the same way as it was before, all real numbers. But if I am trying to look, like on this one where I'm trying to find the range, I could go in and put in my function and then look at it. So for range, it looks like, again, it starts at 0 and goes up. So y is greater than 0. So I'll let you look at that, but my suggestion is definitely to use a calculator. Ooh, what happens here? 5. And then x plus 6. I think we have to put parentheses. Let's do that. X plus. So there, 5 to the x plus 6 power is going to shift it, right? Look, it shifted it over. But it's still, this is still going to keep going in both directions forever. If you think about zooming out, it's still going to be moving forward. So the range starts at 0 again and goes up. So even though they look different, I'm sure you're going to get the idea over time that they really kind of function the same. So good luck.